Just Right. Searching for the Goldilocks Planet by Curtis Manley. Illustrated by Jessica Lannon. When you look towards the stars, do you ever wonder if anyone is looking back? Is Earth the only planet with intelligent life? Is it the only planet with life at all? Our sun is a star. In the night sky are all kinds of stars, more than you could ever count. There are about 300 billion in just our own Milky Way galaxy. In distant galaxies are many trillions more. Could some of those stars also have planets circling them? Even thousands of years ago, some people believed that other worlds must exist. But not until 1995, nearly 400 years after the telescope was invented, did astronomers finally prove that some other stars really do have planets. It is in the highest degree unlikely that this Earth and this sky are the only ones to have been created. Empty space is like a kingdom, and heaven and earth are more than single individual persons in that kingdom. There are countless suns and countless earths, all rotating around their suns in exactly the same way as the 7 planets of our system. So many suns, so many earths. Once we knew they existed, we created a name for them: extrasolar planets, or exoplanets for short. Now we wonder if any of those exoplanets are like our Earth. And if there are Earth-like exoplanets, do they have life? And if there's other life, is it like us? You know the story of Goldilocks and the 3 bears? Goldilocks finds a bowl of porridge, a chair, and a bed that are just right for her. Not too hot and not too cold. Not too big and not too small. Not too soft and not too hard. Our home, the planet Earth, has everything just right for us. Earth orbits in our solar system's habitable zone, where a planet can have liquid water on its surface because its distance from the sun keeps the planet temperature just right, not too hot so all the water doesn't evaporate, and not too cold so all the water doesn't freeze. But liquid water isn't the only thing that matters. Earth is just right for other reasons, too. Earth is big enough that part of its core is still molten, swirling with so much iron that it creates a magnetic field, strong enough to protect our atmosphere from the solar winds. Earth's atmosphere is thick enough that it keeps our oceans from drying up, and its oxygen lets us breathe. Without liquid water, a strong magnetic field, and a thick atmosphere with lots of oxygen, life on Earth would be very different, or maybe even impossible. But could there be life that's different from life on Earth? We don't know if other kinds of life are possible, or where to look for them. We can only look for what we do know: life that's like the life on Earth. So we look into the darkness, where stars like our own sun seem like specks of light, almost too faint to see. Planets are much smaller than stars, and they don't shine on their own. For a few stars that are close to Earth, large telescopes can actually see an exoplanet, but only if the glare from that star is blocked, like when you hide the moon's glow with your hand. But for stars that are much farther away, astronomers use powerful telescopes on mountaintops or floating in space. Kepler. Launched in 2009, Kepler is a telescope that orbits the sun and continuously watches a small portion of the sky to find Earth-sized exoplanets. Part of Kepler's mission is to tell us how common Earth-like exoplanets are in the universe. W.M. Keck Observatory. This two-telescope observatory sits on a mountaintop in Hawaii and has helped scientists discover more exoplanets than any other ground-based telescope so far. Keck's location, surrounded by the Pacific Ocean, provides excellent clarity for viewing the stars. James Webb Space Telescope. As big as a tennis court, the James Webb Space Telescope is designed to look for infrared light, a spectrum that's invisible to our eyes. This space telescope will help us investigate how solar systems form. TESS, Transiting Exoplanet Survey Satellite. With 4 cameras, TESS will monitor over 200,000 stars to watch for tiny changes in brightness caused by exoplanets passing in front of the stars or transiting. Even those powerful telescopes must use special methods for looking at starlight to reveal the tiny clues that show some stars are not alone. All stars twinkle, but some stars also seem to wink at us. Bright, then dim, then bright again, as if saying, "I know a secret." A wink tells us that an orbiting planet blocks some of its starlight each time it passes between the star and us. This is the transit method of finding exoplanets. Some stars seem to wave at us, wobbling slightly one way and then another, as if trying to get our attention. Waving tells us that an orbiting planet is tugging the star around and around with its gravity, like a puppy on a leash, running circles around you. This is the radial velocity method of finding exoplanets. Other stars seem to change color slightly, like a mirror reflecting different light as it moves. And some stars show signs of chemicals that only planets can have. Those clues tell us that an orbiting planet is reflecting or changing the light of its star. These are spectroscopy methods of finding exoplanets. By looking at only tiny portions of the night sky, astronomers have found roughly 4,000 exoplanets. Based on that small sample, we now believe that most stars in our galaxy have at least one planet orbiting them. When astronomers discover a new exoplanet, they can usually figure out how large it is by how much it affects its star's light, and how close it is to its star by how quickly it orbits. Kepler 16b. Type, gas giant. Size, 7/500th times Jupiter. Discovered, 2011. Distance, 196 light years from Earth. This planet orbits a pair of stars instead of just one. If you could float on the cloud tops, you would see 2 sunsets. Kepler 16b is just inside the habitable zone, but as a gas giant, it is unlikely to be suitable for life. If the new exoplanet is very large, it's probably a gas giant like Jupiter, so we call it Jupiter. If the exoplanet is smaller than Jupiter, but still much larger than Earth, we call it Neptune. A gas giant that orbits very close to its star is a hot Jupiter, or a hot Neptune. WASP 12b. Type, gas giant. Size, 1.9 times Jupiter. Discovered, 2008. Distance, 1,300 light years from Earth. This planet is very close to its sun, so close that it only takes over 1 Earth day to go all the way around. When a planet is this close, a star's gravity can pull the planet into an egg shape. The star is sucking away the planet's atmosphere and melting its surface, and it will eventually consume the planet completely. TRAPPIST-1. Type, star system with 7 rocky planets. Size of planets, zero point 0.5 to 1.5 times Earth. Discovered 2015 to 2017. Distance 39.5 light years from Earth. The rocky planets of the TRAPPIST-1 star system all orbit very close together. 3 of the planets are within the habitable zone of the red dwarf star. Could there be life on these other Earths? Like Earth and Mars, small exoplanets are probably rocky, so we call them Earth-like. If they are much bigger than Earth but smaller than Neptune, we call them super-Earths. Astronomers have found many rocky exoplanets. Most of them are super-Earths, but some are only slightly larger or slightly smaller than our planet. As we keep searching, we'll discover more. We've already found a few Earth-sized exoplanets orbiting within the habitable zones of their stars, and astronomers estimate there may be 11 billion more of them just in our galaxy. Now scientists wonder if any of these rocky planets have water, or an atmosphere with clouds and wind like Earth does. We don't know yet. Only the stronger telescopes of the future will tell us. As astronomers search thousands of stars for signs of planets, they also watch for signs of life as we know it. They watch for certain chemicals in a planet's atmosphere, like oxygen from plants and methane from animals. They watch for signals like those we use, for TV and radios and cell phones and GPS. They watch for evidence of huge structures orbiting those stars. So far, they found no proof of life elsewhere. So far, we seem to be alone in the universe. But as telescopes get bigger and better, and as we watch more and more stars, the chances of finding life improve. What might that life be like? It could simply be algae floating in the warm seas and filling the planet's atmosphere with oxygen. It could be things with many legs skittering over a shallow seafloor. It could be plants like grasses and trees and tiny creatures leaping from branch to branch. Maybe it's beings like ourselves, looking up at the stars and wondering. Or maybe it's like nothing we can even imagine. If someday we do find evidence of beings like ourselves, what could we do? Even nearby stars are so far away that going to there might be impossible. But a radio message could reach them in 4 or 10 or 20 years. Should we stay quiet and hide from them? Or should we send a message? And if we do send a message, what should we say? We could say, "Hello, we're glad we're not alone." We could give them the solutions to useful math problems or recipes for making strong metals. We could send them art and poetry and music. Or we could tell the story of exactly how we found them by searching many thousands of stars for a planet that had everything we find familiar, a planet much like our own, a Goldilocks planet, a planet that's just right.